Very warm welcome to everyone. I am M.V.S from BSc MSDS.
My name is Ramakrishna from final year BSc MSDS.
I am Anusha from BCA second year.
I am Sunitha from second year BCom.
I am Shashi Preetham from BCA second year. As everyone can see, our project name is Automated Detection of Lightning by using satellite data and machine learning, a novel and effective approach for disaster management. Our department have luckily academic collaboration with Indian National Center for Ocean Information Service. It is one of the national scientific organization under the government of India. We had several visits and we visited number of scientists, and one of the pioneer scientists, Dr. SambasivaRao sir, who had specialized in remote sensing. While we are interacting with him, he said that every year 26,000 people are losing their lives due to light striking, and there is a lot of social damage. It's a tragedy we no longer ignore. That's why we are standing here with a solution, our project will save lots of people's lives and society. Now let's dive into our project. For this, we need the information of cloud and the data of cloud. As it is humanly not possible, we are using the satellites. Here we use a NOVA satellite. When the sensor detect the light, due to the high intensity of light, sensor will overwhelm and become sensor blooming. Sensor blooming will directly hit on the images. Now let's see how light is detected. Lightning comes from cumulonimbus clouds because it is very with high uplift and with very low temperature of -40 degrees, and it is an ideal condition for the lightning. But here we have a problem. Detection of lightning was easy, but due to the high intensity of light, sensor is going under sensor blooming. Sensor blooming will make us to accurate to get hard accurate data. But we have a solution. To get accurate data, we are using machine learning algorithms. Our machine learning algorithms will take the data of satellite image and cloud top temperature, and by comparing this, it will enhance the light strikings.
Let us see software environment. Here we are using Python language, and in this Python language we are using some library keys, namely GDOL, Matplotlib, OpenCV, scikit-learn, XGBoost. Here in this project we are using GDOL for cropping and for geospatial raster data, OpenCV for visualizing, and XGBoost for build up the machine learning models.
We continue with the methodology. In this methodology, we are having two steps. In the first step, we are converting the grayscale image into the RGB color band. In the next step, we are applying the thresholding on the RGB color band. In the first step, we are collecting the grayscale image from the satellite and we are converting into the RGB color band. In this RGB color band, we are providing a better pixel intensity, which will capture in the form of red, blue, green color. In the next step, we are applying the thresholding on the RGB color band, the area wherein we are interested in. The pixel value of red channel is filtered within the range of 60 to 130, and the green channel is filtered within the range of 90 to 150, and the blue channel is filtered within the range of 52 to 10. After filtering all this RGB color band, now we will get the binary image. In this binary image, white pixel represents the lightning, black pixel represents the non-lightning. By using thresholding, we can detect the lightning strike by filtering out the land masses, clouds, and artificial light sources.
Continue. And the next step in our methodology is to create a data set and train the machine learning models for lightning detection by using satellite data. First, we are overlapping the threshold data and cloud temperature data on the top of satellite image data. From this, we are ensuring the consistent data set in pixel locations, and also we are getting a data point from each pixel with the three features, namely satellite image feature, threshold data feature, cloud top temperature feature. Let's go through it. Satellite image feature represents the light intensity in specific spectral band, and second one is threshold data feature, indicates whether a pixel is a part of potential lightning. Third one, cloud temperature feature, represents the temperature profile of the cloud in the image. And finally, a label mask automatically marks the lightning pixels with 1 and non-lightning pixels with 0 based on the lightning strikes region. And we successfully created a data set to train the machine learning models for lightning prediction.
Let me break down how we analyze the data. By using scatter plots, we see the relationships of satellite image, cloud top temperature and threshold data, and distinguish between lightning areas as 1 and non-lightning areas as 0. And by using distribution plots, we see the how these features are spread out. And correlational matrix help us to choose the best future.
Now let me tell you about model training and evaluation. Model training is the process of teaching a machine learning algorithms to recognize patterns from the trained datasets, as well as model evaluation is the testing a trained model on unseen data to recognize its performance and scalability. In our project, we used 3 machine learning models, and they are logistic regression, KNN, and XGBoost. In addition, we used precision, recall, F1 score, and confusion matrix as a primary metrics. With the help of these primary metrics, we can easily access not only the overall accuracy of the model, but also how well its performance is going through each class, particularly when the data is imbalanced, as in the case of lightning detection.
In order to evaluate our model, here we are using the confusion matrix. Confusion matrix will measure the 3 metrics like precision, recall, F1 score. These are the baseline metrics which will increase the performance of our model.
Final prediction. Our models will predict the lightning location by using satellite image in 3 steps. First, masking. It will convert the satellite image into binary masking and label the lightning pixels as 1 and non-lightning pixels as 0. Next, clustering. DBscan will cluster the lightning pixels into one cluster and calculate the XY coordinates. Next, geographical conversion. Now pixel coordinates are converted into geographical coordinates. These are the real world coordinates.
Conclude the project. In this project, we created a methodology to detect the lightning strike through the satellite image, and by using the machine learning, we started solving an issue on sensor blooming by using the custom thresholding function by filtering out the land masses, clouds, and artificial light sources. We started collecting the data by combining the satellite image, threshold image, and cloud top temperature. By analyzing this data, we trained 3 models. They are XGBoost, KNN, and logistic regression. To enhance the performance of these models, here we are using some metrics like precision, recall, F1 score, confusion matrix to detect the lightning strike by minimizing the false positive, false negative. Finally, here we are using clustering technique by to give the exact location of the lightning. We are converting them into the real world geographical coordinates.
Our project is a solid contribution for detecting the lightning. This could be prime source for alerting the government for immediate action.
Thankful to our project supervisor Dr. SambasivaRao sir and Dr. K. Padmavati madam, principal of our college, and we are very thankful to Dr. N. Srinivas Rao sir and Dr. S.P. Vigneshwar sir and Dr. Balakrishna and sir, Director of Indian National Center for Ocean Information Service.